Hello, hi everyone. Very good evening to all. Can I get a quick confirmation in the chat window? Am I clearly audible to everyone, those who have joined me live? A very good evening to all. Just a quick confirmation on whether I'm clearly audible, properly visible or not. Okay, people are joining. So I think YouTube gives notification once we start the live. So we will wait for a few minutes and then we will start our very interesting discussion today. Uh, it's going to be very interesting session for sure because here we will be talking about end-to-end project. Um, so in the meantime, people are joining. Let me introduce our guest for today, and he's Arijit. I hope you have seen him previously as well. Hi Arijit, how are you?
Yeah, I'm doing good. Hopefully you are as well. I'm very excited to join you for the second time here, and let's see. Let's have a productive discussion.
Yes. So, if you guys remember previously, he with his one of his friend, right, Arijit? There was one of your friend also, Sudarshan. You guys have explained how the complete EDA works in stats and the complete end-to-end workflow of that. Um, by the way, he's one of the learner. I think you have been from a DSA one batch, right? You have
Yep.
joined my very initial batch of DSA almost 2 years back. So from that specific batch, he is a very consistent one, and again he joined full stack data science batch, which was the previous year batch, and it gets finished now, and he has created a end-to-end machine learning project which he wants to demonstrate with us today. So I really want everyone to be very much active over here and uh, try to listen him out whatever learnings he wants to share with you all, because इट्स लाइक जब हम किसी की गलतियों से सीखते हैं, जब हम किसी के चैलेंजेस को देख के सीखते हैं, वी विल लर्न इन अ वेरी बेटर मैनर, राइट? And that's what is your learning for today. So those who have joined us live and even those people who will watch the recordings after the discussion will be over, try to take this as an inspiration. Try to learn as much as you can from this session, and maybe after this discussion also, if you have any doubts, any questions, you can always reach out to him or me, or you can write in the comment section. We will try to respond to you as soon as possible. Now, before he will start and take over the stage, I will just give you a gist of what we will going to do over here, uh, just to give you an idea, everyone who have joined us live, and then maybe I will hand over the stage to Arijit. So, Arijit, you can relax for a few minutes, and then maybe I'll share the stage to you. Okay. So, what we will do today, I hope everybody knows that when we talk about machine learning or any data science project, there is a complete end to end workflow for that. Uh, for example, if let's say any business problem is provided to you, maybe via the clients, maybe via your manager, the very first step is to understand that business problem, right? We have to, think, we have to understand that what is this use case is all about. Maybe to understand that in a deeper context, some domain knowledge is required. That maybe you can, if when you interact with the clients multiple times, when you have multiple meetings with them, you will be able to get a better understanding of it. Once you're good with the business understanding, the second important step is, as per that, how can we collect the data? In data collection part, depending upon which specific use case you are solving, depending upon what specific domain you are solving, it might be challenging, it might be easier task as well, we don't know. Assuming that it is easy for you and you will be able to fetch the data also, the story doesn't stop there. Once we get the data, the data can be a raw data, it can contain missing values, it can contain outliers, it can contain null values, it can contain empty blocks, it can contain uh, any you know inappropriate type values as well. So we have to treat all of these values in a very conscious way, so that we will not able to lose the information, but at the same time we will be able to transform that data in an appropriate way so that we can make a better use of it. Our model will be able to understand the data in a more appropriate manner. अब उसके लिए हमारे पास बहुत सारी टेक्निक्स होती हैं, एंड आई थिंक आई हैव अ डेडिकेटेड स्टैट्स प्लेलिस्ट. इफ यू विल गो एंड चेक दैट आउट, you will observe that mathematics plays a very important role over there. In our last discussion with Arijit, he has also mentioned about how he has done EDA on any specific data in an industry style manner. You can go and check that out as well. And over there, you will find that there are so many techniques we have to do the EDA stuff. Once the EDA will be done, once you will be able to get a quality data, the next step is, maybe if you have a lack of data, you will do data augmentation. You will try to uh, you know generate a data, synthetic data, which may be artificial, which is not realistic, if that is not feasible to you. So that is something which we usually do before going towards a model training phase. Now, once our entire data pipeline is ready, we will go ahead and start our model training. Over there, there might be a single model you're using. There might be parallel execution you are doing, depending upon what sort of problem you are solving. And once you are ready with the model, once you know that this model is giving me a very good results, you will go ahead and evaluate that, and finally you will deploy that in the production side. That's the overall pipeline of any project. It looks like, right? Depending upon what specific project you will be solving, challenges are different, right? So today, Arijit will showcase to us what he has built end to end, with the pipeline part, whatever phases I have talked about. He'll talk about every phase with respect to his data, with respect to his work, what are the specific challenges he has faced. All those things we will learn from this discussion. Now, if you have any questions in between, you can keep on posting those questions in the chat window so that we will take all of those questions at the very end from him. And I really hope that this will be a very informative session for everyone. So, Arijit, you can now share your screen and maybe you can start your discussion.
Let me know whenever my screen is visible.
Yep, it's visible clearly. Go ahead.
So, firstly, I'll show you the structure of the final project, and I'll also at the same time I'll show you the Jupyter notebook that we typically use and how and why this decision was taken to structure it like this. Now, I am not an ML professional, to be very honest, so I was looking into how in a real life project in machine learning engineering, what they typically do when it comes to their projects. How is it different from ordinary software engineering, so to speak? So there are multiple ways to go about it, but one thing is certain: Jupyter notebooks do not get pushed into production. So typically there will be something of an orchestrator which will have different, like there are, I will put a few names here. You can look into those yourself. One of them is like Kubeflow, one is Airflow. So what they do is you have certain scripts ready, which they will run either parallelly or sequentially, and that will constitute a machine learning pipeline, so to speak. So in my case, if you see here, these are the steps, like these are the stages, you can say. In data engineering and augmentation stage, we will ingest and clean the data, right? Extract, transform, and load. ETL is extract, transform, and load pipeline. Many of you, if you guys are into data analysis or engineering, might be familiar with this term. So the purpose of this is to ingest the raw CSV, and to we will do the cleaning and whatnot. And then in my case, I have transformed it into a Parquet format. Now, Parquet is another like I may be mispronouncing it, but I'm calling it Parquet. Parquet is another format of data similar to CSV, but there is a reason why I have transformed it into a Parquet format. Like one is that it enforces strict data structure, like basically, it enforces strict schema and it preserves the data types. For example, you might have noticed one particular problem when you get any CSV file from, say, Kaggle or something, that the postal code or any such numeric string, which is not supposed to be integer, right? It might get converted into an integer. The date time might be weird. So those problems we might face in CSV. Parquet solves this because it enforces a strict schema. First, secondly, the performance is significantly faster, especially in large data sets. Like the difference in performance won't be that visible in the typical small data sets that we do our demo projects in. But in the industry where you're dealing with millions of rows of data, that becomes very visible. So it's a better practice to transform or convert your data into Parquet. So that is step number one. Then typically nobody would do like in at least in industry they would not do like one by one EDA like similar to what we have done in our previous discussion. So there would always be some sort of automated script, like yes, for very specific data and data which has a particular structure, you might add a few steps or not, or I mean that kind of additions and subtractions might happen, but there would typically be an automated EDA report generated which will show you a wide variety of things. So that is the second script that I had written. It has a lot of things in common with the discussion we have had earlier. I would show you the reports as well. I mean, I think some of them those will be familiar to you. For example, this, like say it will for example here what is happening for category, what are the counts of the different okay, before that, sorry, I'll again show you the raw data set once. It's a 10,000 row data set. Just a second. Maybe I'll open it in data wrangler. Yes. So it's a 10,000 row data set, and obviously there are missing data and all of the other deformities that there are. As you can see, the columns are what? Row ID, order date, ship mode, customer ID, customer name, segment. So basically, this is the data that a superstore is basically like a shopping mall or shopping store. They have collated over a period of time. It is from the USA, and what we are trying to do in this project is to first we want to maybe predict profitability of a new product that might get introduced. Secondly, we will try to do some sort of market basket. What is a market basket again? When you are doing a shopping on Amazon, so sometimes you will put something in your cart and they would say, hey, do you want to buy this also? So that is a market basket. So we want always, as a store or a shop, we want to sell more things to our customer, and that is what that market basket analysis will do. So that would be point number two. And point number three is we also want to segment our customers into meaningful groups so that we can design dedicated marketing programs for them. And in the industry, not just in e-commerce, in any sort of industry, whether it be health insurance or any sort of marketing industry, you would find that this is a very prevalent practice. Even in Zomato, for example, I got to know this very recently, that sometimes you may raise a complaint in Zomato, and sometimes you will immediately get refunds. But some people, they never get refunds, or they would tell you that okay, we can only give you like 5% or 2%. We cannot refund you, although the food that you have received is bad or maybe didn't get delivered. Now, how is that actually done? Basically, I got to know that there is a tier listing of customers based on the kind of complaints and how frequently they have raised complaints on their platform, like gold, silver, iron, something like that. Okay, I'm not exactly sure of the nomenclature. So how do you segment the customers in such a way? It's similar in Amazon and Flipkart as well. Maybe there are people who return their products a lot, so they would be put in a lower tier specifically. The more you do it, the lesser the chance that you will get a full refund or a good, support from the customer service, basically. So this is something that we want to do here. We want to divide our customers into meaningful segments. And last, I have added another section called explainability, which means that which features are more important. Like, see, machine learning, there is a problem with machine learning or neural networks or large language models in general. They are called black box problems because we often don't understand how the model is actually working, like what is actually important. So this explainability of a machine learning algorithm is an important and growing demand from the industry as well. So I have tried to add that concept here as well, which if the time permits, I'll definitely get into. So that is a basic idea of what I'm trying to do here. I will try to cover as much as possible, but there is no hurry, there is no rush. It's more about the learnings, the mistakes that I have done, and what I have learned from them. And it's important to have fun while doing so. If you don't enjoy the process, I don't think you will be able to do all these things. Like, after all, running a model is not that difficult. It's about the kind of learnings you can get from the mistakes. I'll show you one example of that later on. Okay, coming back to the steps, right? So there would be an automated EDA report that will be generated. Then
Arijit,
you can augment. Yeah,
sorry to interrupt. Can you just hide the below button? Stop sharing and hide. Hide is there. Yeah,
yeah.
perfect.
Is that fine?
Yeah.
Okay. Thank you. So the third stage would be typically data augmentation. Now I'll want to talk a bit about it. So in many industries or in many scenarios, you might not have enough data. That is a common problem. Like, that's one of the most common problems out there. Like, people who are not directly into software engineering or data science, even they face this issue. For example, one of my friends is in PhD, and he's trying to do some sort of analysis on mindfulness or something. The problem is, I mean, okay, you want to do this analysis, but there is not enough data. Like, maybe you can interview 50 students at max. You can ask 100 of your friends, if you have 100 friends, to fill out a questionnaire. But that is not enough data for a model to meaningfully learn and not to overfit or underfit, basically. So data augmentation becomes a priority. Another example of that is especially relevant in the medical field, where some rare diseases, not even rare diseases, some specific um, like situations do not have a lot of examples. Like, I know one such instance where the pathology report of someone, the pathology of how a particular disease spreads was being investigated, but there are only like 3 or 4 people which they could find with that particular pathology. So what do you do in those scenarios? So data augmentation is a very important step that we have to take in that scenario. Okay, so I talked about the initial stage, right? This is data engineering and augmentation. So I can maybe show you the Jupyter notebook, which is the scratchpad basically. Now, the difference between the scripts here and the Jupyter notebook is very simple. The Jupyter notebook is there for you to try out your ideas. You generate your plots, you see if the models are being generated, and then when it comes to actually pushing that to production, then you have to create those scripts, and something like an orchestrator can orchestrate it. So I'll be switching to the Jupyter notebook here. Okay. As I mentioned earlier, I have shown you the CSV data, right? And I have converted that into a Parquet format as well. Now, that conversion is actually pretty easy to do using Panda, so I'll not be going in depth about. So what I'll show you here is synthetic data generation and why it was necessary. So the dataset that I had only like 10,000 rows. While that can also work, we want, if you want to generate deep insights about any sort of field, we want more data. So what am I using here for that? That is, I am using something called CTGAN. GAN is a generative adversarial network. It is also a sort of generative AI. And this is another interesting thing. LLMs are not the only sort of generative AI out there, and there have been other types of generative AI out there. And one of these is this conditional tabular generative adversarial network, or CTGAN. So what it does is it creates realistic synthetic data by learning from the patterns within the data that you give it. It is not the same thing as oversampling or other such techniques we use to create synthetic data. Like SMOT is one of those techniques, right? If you can learn more about it from other videos that Priya and others have put out, but here it is doing something very different. So it is trying to create realistic data from the data set that you are giving to it. And how does it do it? I mean, it is it is a neural network, so I'm not going to go in too much in depth about it, but I would definitely ask you to look into this when it comes to synthetic data generation. Now, what is the problem that I face? I can talk about that. Now, one of these columns, that one of these categorical features in my case, product name had like 1718 unique values. Now, what happens is when the CTGAN synthesizer prepares this data, it tries to one hot encode it. If you guys are familiar with it, one hot encoding means that it is trying to, I mean, it will basically the cardinality of that column will explode. Like there will be so many columns created just to one hot encode that data. That will be a huge problem basically, and it will not learn anything meaningful from it. So if we want to generate realistic data for our models, we have to ensure that we are not putting such high cardinality categorical features in this particular like synthetic data generator. So definitely what we'll have to do is we have to understand which columns we can actually use here. So definitely when you are doing the value counts for each column, you can get the number of unique values, right? That will give you some idea here. So right, so that is what I did in the first case. So I created a lean data frame. The lean data frame just means that all of these columns I had selected which do not have a high cardinality value, and then simply I have run the CTGAN synthesizer, the the CTGAN synthesizer module, and that will generate the synthetic data. Now you can ask a question here. Okay, you said that you have generated synthetic data. How do I know that it is even relevant? How do I know that it is a credible synthetic data? Now that is a very good question. We can actually learn, we can actually check that. Now synthetic data vault is again another open source Python library that we can use to evaluate the data that is generated here. Obviously we cannot, since synthetic data that I have generated is like I generated 20,000 extra rows, so a total of 30,000 rows are there now in the synthetic data frame, in the synthetic plus actual data frame. Obviously we cannot evaluate like this, that hey, is that synthetic data correct, like credible, not correct, credible, I mean, does that make sense? So it has a function called evaluate quality that gives you a statistical score whether that data is actually credible or not. So there are some internal tests that it runs that I'll not go in depth into, but I'll show you how you can get an intuitive idea about what it does. So here is an example of that. Now the gray colored histogram that you see is the distribution of the values for sales price of the real data, and the teal colored histogram that you see is that of the synthetic data. Now you can see one thing very clearly, that the synthetic data is almost mirroring the distribution of the real data, and that is exactly what we want. We wanted a large amount of data which actually reflects the patterns that are there within our actual data, right? And similarly for the profit column as well, you see that it kind of mirrors, it's not exactly the same, but it kind of mirrors the shape of the profit data, right? Same with discount. Now for categorical data, you can again see this is the real data where south, I mean, south is the region basically, and this is for west, central, east. All of these are sort of very close to each other, right? Same with say category. Like you can see that the relative distribution is very similar. So that is exactly what we want when it comes to synthetic data. And there is also this correlation matrix. If you see, this is for the real data, the correlation matrix, and this is for the synthetic data. It almost kind of it's almost the same, if not exactly. Like there are obviously slight variations, but that is fine. So that is one learning opportunity for you here. That if you don't have enough data, you can definitely generate synthetic data, but that just generating it won't be sufficient. We should definitely evaluate the quality of it, and based on that, we will decide whether that data is fit for use. So here I have, there is a score here that I have generated. Let me see if I can find that. Yes, the data quality score is like 88.1%, and this is coming from that SDV library. Let me show you.
This is one of the most important part of this entire session, I would say, because I have seen so many people working in the companies and they think that simply generating a synthetic data completes their work. Now they have a data and they can directly go for model feeding and all those things. Actually, if you know about the mathematical things, you actually understand the literal meaning of distribution, and why it is important that when you generate any synthetic data, be it any technique you're applying, the distribution will remain the same as per the original one. Then only your results will be good, then only you will be able to train a sensible data, and you will be able to get a better accuracy out of it. So that is where I think he has done a very amazing job, I must say. Great, Arijit. Yeah, please go ahead.
Yeah. So this evaluate quality, as I mentioned earlier, SDV is a Python library that you can import, and it has an evaluate quality function which will run some mathematical tests underneath. I have written those down, and I'll share this with you as well. You can, if you want, you can go into deep dive into it, which I am not going to go right now. But yeah, this is something to understand, right? So now we have synthetic data, and yeah, the overall score here. I put a boundary here that if the score that this library generates, only if it is above 75%, I will consider this to be credible data and use it. Otherwise, we'll have to look for some other technique. So the overall score here was 88.1%. That's why I went ahead with it. Anyway, just name dropping this test. Okay, this is called Kolmogorov-Smirnov test, which overlays the histograms, and if the curves overlap perfectly, that basically means the synthetic data is exactly the same distribution as the real data. And if not, then it will give you a basically 0 to 100% score, right? Okay, and there is this another column pair trends, which is the correlation matrix that I showed you already. Okay, now enough talking about the synthetic data. Now we have the synthetic data. Now what do we do? Now here I will tell you another interesting story from my journey. So initially, I wanted to predict profit, right? And to predict profit, I said, okay, profit is my target variable. So what can I use as features? I added everything in the features column, like sales, region, discount, all of these things, right? I'll see whether I have that here. Okay, probably not. That is fine. Mm, right. Wait. I'll show you. I think I have it. Mhm. Okay, so I am not able to find that exact clone because I have actually discarded that model, and I'll just tell you why I have done that. So basically, in my previous attempt, I had added sales, profit, and all of sales, discount, total sales, average sales, and a lot of other features that were there in the original. Like if you see here, it has these columns, right? It has say yeah, here it has say sales price, it has quantity, discount, all of these things. So let's say you are someone who is a novice in machine learning, and you think, okay, good enough, like I have profit and I have sales price, quantity, all of these things, and by having these as features, I'll just compute the profit. Well and good. What would happen is you will get like 90% plus 99% accuracy, and you would be very happy. But the problem is, what you just did is wrong. You basically leaked the target. This is called target leakage. Okay, what happened here is profit has a direct correlation with with these features like sales, discount, and all of this, right? I mean, it's just a mathematical formula, right? If you have sales, discount, etc. in your features, and then you calculate profit, I mean, you try to predict profit, it will give you a very high accuracy score, but it tells you nothing about whether a particular new product will be profitable or not. So therefore, in the next time, I eliminated a few of these features and only tried to train the model based on the features that, let's imagine, okay, what are we trying to do? We are trying to say, okay, a new product is we want to introduce a new product into the market. Will it be profitable? If yes, what kind of profits can we expect? Now, when these two questions are being asked, what information do we already have? Do we have the sales numbers? We don't, because it's a new product. So what information do we have? We can have the region, the customer segment to which we are catering to, maybe the category of product, the discount we may be willing to give, and maybe the quantity that is there, right? So if you train your model based on only these data that is available to you before you even introduce the product and there is any sales whatsoever, you can get a more realistic idea about profitability of a particular product. So okay, let's go to that part. So before doing that, I had done another thing here, which is comparing the models against each other. And for that, for example, here I had tried to calculate the profitability. For that, I had compared lasso regression, random forest, and XGBoost. And what I have used to compare them against each other was cross validation. The cross validation score. I mean, if this is something that you are not aware of, I'll give you one example of what cross validation does. Like, let's imagine that one thing that you can do definitely is like, okay, you get the accuracy or the F1 score from a particular data set. Like from a particular train test split, you get like you do an 80-20 train test split, and you get some sort of accuracy, some precision F1 scores from that train test split. But what if that is, I mean, that's just a fluke? How do you know? Like maybe the model just learned the patterns in that training data set and it predicted the testing data set, but you don't know that whether it's some sort of internal fluke, right? How do you be sure that what you have done is that the model has learned the general patterns within the features? So for that, cross validation, what it does is it divides the data itself into different train test splits. Like it will like let's say you say that 80-20 only, right? So it will take different sets of rows, not the same ones. Let's say if you do it 5 times, it will take 5 sets of train test splits. It will calculate the accuracy and other whatever metric you're trying to calculate. It can be r square or whatever, and it will then take a mean of that. So that is what I have tried to calculate here: mean cross validation r squared. And for each of these I have tried to test it, and it gave me these results, which were not pretty good, which were not very good initially. So this is before I had augmented, and here comes another kicker. The reason even this the reason we did this synthetic data generation and all is also because the scores that I was getting from the original 10,000 row data set was not very good, right? So as you can see, so even from XGBoost, it was only like 45.88% R squared, which is not very good at all. So therefore, I decided that okay, we needed to generate some synthetic data. And here in this step, you can see that I am combining and loading the real and the actual and the synthetic data to create an augmented data set. Then I did another piece of work, which is also called feature engineering. So already we have some columns here, but those were not giving me good results. So I thought, okay, maybe we need more features which may be more meaningful. So these are some of the new features that I created. So for example, first or days since first order is one of those features. Postal code profitability, state sales volume, like all of these are all self-explanatory what these features represent. If you have any other queries, we can, I mean, it's pretty obvious what is being done here. Here I would say one thing again. Firstly, I created the profit margin. Profit margin is nothing but the total profit divided by total sales, as you can see here. Then days is the first order that for that particular order. Then the postal code profitability, like now here it is a one feature that you created. Then based on that you create another feature, and we take the mean of that, and that would be for every order. What is the typical profitability expected for that postal code? Same with state sales volume. Again, another thing that I created was the subcategory average margin and the category average discount and category average order size. So you can see I have created a number of new features from the existing ones. So if you ever find that in your model, because of the features that you have, you're not getting good scores, you may look into generating more features. Think about it logically based on whatever type of data set you are dealing with, what would make sense. So these are the features that made sense to me. Like I experimented. I mean, I have not shown here all of the experiments that I have done, but I experimented with other features as well, what works, what doesn't, and ultimately these are the sets of features that work well for me. Right here, you can see these were the ones in capitals are the ones that were there in the data set already. Segment, region, state, category, subcategory, quantity, sales price, discount, and these are the new ones that I had created. So
Arjit,
as
can we
you,
expand the screen, the code file a bit?
Mhm. This one, right?
Maybe
Okay,
left
sure.
table of content you can remove and then expand it. Just zoom out. Yep,
This
yep.
like this.
Great. Yeah.
Okay. Yes. So we were here. So as you can see here, this here, what I am trying to do is to to tell you, given a new product, which is for a given customer segment, region, state, category, subcategory, quantity, and the price and discount that we are willing to give, will it be profitable for the company to introduce that product at all? So that is the target variable. Is profitable. So we did that. We did that. We Now here I'll introduce another concept before I go further, and that is the concept of a pipeline. Now, what is a pipeline? Pipeline is a library that is there in Scikit-learn. I'll move to the explanation that I have written here. So,
In a production grade environment, this pipeline is something which usually we use in order to write the code end to end. Uh, so always remember, one thing is when we are doing a research work, we are exploring. So it's completely fine to go on Collab or Jupyter Notebook and do things step by step. But when you are writing a code in a production environment using this pipeline method actually helps a lot and streamline your work in a very good way. So yeah, please go ahead.
so and another thing that I discovered when I was learning about it was that it also helps prevent data leakage. And how that happens, you are familiar with standard scaler if you are an ML enthusiast. If not, that is fine. So the standard scaler, what it does is, let's imagine that I'll just take one sentence to explain it. Let's say your income is in the ranges of lakhs, let's say, and maybe the age of an employee is in the ranges of tens. So if you put those values as is in the features, it would skew the data, right? I mean, your age is like what, 20, 30, 40. Your income is something like 4, 5 lakhs, 6 lakhs. If any model, whichever model you try to use here, if they try to learn from that pattern, it will give undue emphasis on the income, right? And that happens because the number is bigger. Simple as that. So that is why we do this scaling. We try to put everything on a scale of -1 to 1, or depends on what type of scaler you are using. So for that, it uses the average and the spread of the data. Now the problem with it is, if you are doing this and then you are splitting the same data into training and testing, there might be some sort of data leakage, because your training data was used, right, already. Your already the testing data was part of the scaling process. So obviously you can nullify it by doing it separately, and that is the standard process. But instead of going through all of that, you can just use the pipeline library, and it does all of it for you. Basically, that is the best part about it. It will do all of these steps for you, and it's also a standard way to do this, basically. So I'll recommend that you learn about the pipeline library. It's a part of Scikit-learn only, and I'll show you how it looks like what it would look like here. See, I defined the preprocessor here, which is a column transformer, where I use two different transformers. For the numerical features, I used a standard scaler. For one hot encoders, I use for categorical features, I use the one hot encoder. These are all standard processes. Now, typically, someone who is just getting into machine learning will do all of these steps separately, and that is fine. But we are trying to be more standard and precise or concise about these things, right? Then in the pipeline, you just define the steps that are to be run. So first, you will do pre-processing. Then you will do then you will define the classifier and maybe the evaluation metric. And here, this one just means how many CPU cores you want to give for this. This is not that important, to be very honest. And here I have done another thing. I will not go too much in depth about it. This is part of hyperparameter tuning. For any given machine learning model, there are a number of hyperparameters, right? Maybe in case of XGBoost, there is a number of estimators or depth of the tree. So by tuning those, you might get better results. And but how do you know? Manually, if you try to tune, you can do it n number of times, and you may get good results. Sometimes you may get bad results. So one library that can help you in this scenario is Grid Search CV, right? There, it will basically what it does is it will generate n number of models based on different values of those hyperparameters that you consider to be important, and then it will compare the scores of all those models. Here, for example, the scoring is done on the basis of accuracy, and then it will only give you those. I mean, here I have directly gone for fit, but you can also get the scores actually. I'll show you that as well. Just I'll show you. I'll not go too much in depth into it, but I'll show you how it looks like. Um, let's say here you can see. So here I also ran the grid search CV, and if you want the best parameters, if you take that object only, it has this attribute best params, and if you print it out, you will find the at learning rate 0.1, max depth 5, and estimators 100. It gave the best results. This is what I was talking about. So these are hyperparameters that are intrinsic to a model. All of different models are different hyperparameters. XGBoost, in case of XGBoost, these are the three. For neural networks, there are other hyperparameters. So, so this is how you can do this tuning, and it will give you good results. And if you directly go for dot fit, it will get the best parameters, and it will directly use those. That's what I had done here. Since I already know which classifier to use. In this case, I used the XGBoost classifier, and this also came after I did comparisons between random forest, logistic regression, and XGBoost specifically, right? Um, and after this was done, um, this is just a method though. Sorry, this is just the method, the train final classifier. Similarly, the train final regressor, it is trying to give you the target variable here is total profit, and similar steps here. I mean, we are using a pipeline preprocessor where standard scaler and one hot encoder is being used. We are using XGBoost regressor, not classifier, and it's literally the same process here. Here, just the target variable is different. We are not classifying. We are getting a direct data. And finally, the model pipeline. Now here you would see that okay, I am creating the augmented data frame from the real and the synthetic data. Then I am training the final classifier and the final forecaster here. So all of that happens here, and here there is another lesson to be learned. Now, typically, when you are generating these models and you are generating this course and you are happy with that, that is fine. But what if you want to reuse those models? How will you reuse those models? Basically, you can use a library called joblib. There is also pickle. So here I have used joblib to create, like to save those. I mean, those files basically in my system, so that you can reuse them. And obviously, if I wanted to I mean, if I wanted to again show you and again rerun it, it will take a lot of time to train it, right? And that is not what you want to do in any case. Like for example, if I show you this dashboard that I have made here, the prediction suite is using that model internally. but it is not doing the training. It is not doing the training right here, right? Matlab, the models are already there in its internal memory. It is just using it to generate a prediction directly. So that is another learning step that there's there. So coming back to this, I mean, this is pretty much what I have done here, and the pitfalls that I have explained. That initially you have to be very careful about the features that you are putting in the target variable. You have to compare the different models and pick the best one. How will you do the comparison? You will use cross validation scores so that it is not dependent on a single train test split and it's not a fluke. You can improve the performance of your model by the use of grid search CV. This is called hyperparameter tuning. You can learn about that. I mean, in other videos of Priya or and in any other ML content if you see. And ultimately, you have this particular thing would be done, and you will have your two models here. One is for the classification, and one is for the forecasting of profit. And I have also explained why I have dropped certain features here. So I think I'm good to move to the next part of this project, and that is the market basket analysis. Now, here there is something called a cold start problem. So what happens in market basket analysis in the classic sense? What happens is you have a list, like you have this this historical data that okay, traditionally with notebooks pens are sold, good enough. But what if you want to introduce a completely new category of products, right? That you have never sold before. Let's say let's say book company, they want to sell tablets. Ebook readers, something like that. So that category of products, that particular type of product has never been sold before. So that is called a cold start. So how would you, predict what goes with that product, right? So that is basically the flaw with classic basket analysis. So therefore, what we will do here is we will treat this problem as a supervised classification problem. So if we create a data set of item pairs like item A and item B, the model is trying to predict, are these two items going to be likely to be bought together, right? So for to do this, what are the features that are important? So let's say there are two items, right? Category item A, item B, and we are trying to predict whether these can be bought together. So in here, what I have used is the category and the subcategory features, and also the sales price typically. Now, why the sales price? Because typically you would see that when you buy something expensive, let's say a laptop, they may give you a pen drive for free, a mouse for free. So this is an example of market basket basically. So if someone is buying something that is expensive, maybe they would also buy something that is a little bit less expensive if it matches the category of product that they're buying. So that is what we are trying to predict here. Okay. So fine. So how did we do this? Now, if you see in our original data, I'll show you the data once, and then you'll understand like what I'm trying to say here. So here there is a column order ID. Yes. So here there is a column called order ID, which basically means if you see the first two order IDs are same, means these are two separate products that were bought together. That is what we know. That is what we understand by order ID. So this gives us a pretty good clue to which kinds of products are likely to be bought together, right? So what I am trying to do here is see if you see this particular I mean line of code, we are trying to get positive pairs and negative pairs, right? Positive pairs just means that all of those products that belong to the same order ID give me all combinations of those products. That will be our positive pairs. And we'll create a data frame where we'll say, okay, these are all purchased together. Similarly, negative pairs would be all those products who were never part of the same order ID, right? Great. and I create another data frame here with negative pairs of products, and here I create this feature purchase together as 0. Here the purchase together is 1. Then we create a merged data frame where we are merging the negative pairs with the positive pairs on the purchase together axis. Sorry, on the product A and product B axis, and we are doing a left join here. So when you see, when you like print it out, I think the printing it's the definition here. Sorry. So you have this merged data frame which has what columns right now? It has product A, product B, whether they were purchased together or not, right? And after doing that, we also calculate the average sales price of those. We also add, yeah. So we also add the category of that product, the subcategory of that product, the average sales price of those two products, right? So ultimately, this is how we create all of these features. So here it gives you all the data: 7,001 positive co-purchase pairs, 13,959 one negative co-purchase pairs. So finally, this data set that I have created by using this method has like almost 21,000 rows, right? So this should be pretty clear what I have done here. If you want to go more depth, you can go into the code and see how you can create those pairs. But this is the basic logic. And what is the target that we are trying to predict? Whether they will be purchased together or not. That is exactly what we want to predict. Here, what we want to understand is, given a particular category and subcategory of a product, given a particular sales price, would these three things actually matter in their being purchased together or not? Out of these, obviously, the numerical features would be the sales price of product A and product B, and the categorical features will be the others, which is pretty obvious. We use the same methodology here, the preprocessor, where we use standard scaler and one-hot encoder. And then I tested out again the three models: logistic regression, random forest, and XGBoost Y. Out of XGBoost, it is XGB classifier. Specifically, we are trying to classify after all, right? And then it's just a for loop where I run the pipeline separately for each of them. We are calculating the cross validation scores for each of them, then getting the the mean F1 scores for each of them, and ultimately whichever one is the best, we will be utilizing that. So here you see what happened here. So logistic regression, the mean cross validation F1 weighted score is 60%. For random forest it was 63%, and for XGBoost it was around 65%. Now I can understand that you might say that, hey, this is not a great score. Like, this is 64-65% is not a huge score. But understand what we're trying to do here. We're trying to kind of suggest to a customer that, hey, do you want to buy this product? If there is even that percent likelihood that they would buy that product, we will suggest it. So 65% or 70% score in this particular regard is not that bad of a score considering the use case. It would be a very bad score if it was something like a medical emergency, a medical diagnosis or something like that. But here it is fine. So that's great. Now, coming to the next part. So again, if you, I forgot to mention one thing. So here, what happens is, after I got the best model, I just, if you see here in the code itself, the best model would be saved as a joblib file, and that is exactly what I have done. The files you can see here in the models part, you would see the predictive MBA classifier.joblib. That is exactly the file that we created here, right? So, and that file would be used where I'll show you that as well. Here, product recommender. So let's say you can select any given product here, right? Let's say this. All of these products are actually taken from the dataset itself, and you select any other product from here, and you see here, this is pretty obvious now. Now, if you take these two products, the predicted probability of these two products being purchased together is only like 9.269%. But let's say I take something else, like maybe some sort of binder and maybe node or pen. So it seems like a binder and a sharpener has, almost the likelihood of 70% of being bought together. So utilizing it, you can upsell, you can sell more products to your customer. So that was basically the purpose of creating that market basket. Now we'll move on to the third part of our project, and that is creating meaningful segments for our customers. Now, if you know about machine learning, I mean, most of the algorithms, you know about clustering algorithms, and one of the most popular clustering algorithms is k-means clustering, where we are trying to determine from like so okay. So k-means does what exactly? I will not go in depth because that would take a lot of time, and you can look into other videos into what exactly it does. So what I'll show you is what happened when when I did basic k-means and how it how it helped, or how the results were not good enough, and what I did to fix it, so to speak. Right. So this is what actually happened when I initially did the k-means. So there is something called an elbow method, or there is another thing called a silhouette score method. This basically tells you that given a set of unsupervised data points, like if you are given a set of data points, how many groups, I mean, makes, or how many clusters gives you the best possible split, right? So when I did that, first of all, the elbow method was it's not a very good curve. Typically, the elbow method would show you that there will be lowest point, and then it's called an elbow because the rest of the point should be above that lowest point. But that is not what happened here. And even in terms of the silhouette score method, which is used to judge how good your clusters are, it only scored around 37 to 38%. Right? Yeah, here this is exactly what I had like written down. The curve flattened after k equal to 4, which means that okay, the optimal k may be between 3 to 5, and it is ambiguous because the elbow is not sharply defined, and the silhouette score is used to measure the cluster density and separation for each k. The analysis show a 37 a score of 0.37. It is not very good actually, honestly speaking. So what is this again? So here basically I will not go into in depth into it, but I'll just tell you that you can look into what inertia means in terms of k-means clustering, and what happens when you directly apply k-means on this. Before that, I have done another thing that I have forgot to mention, and that is for customer segmentation, what kind of data is important. So this I have also explained in my previous video. We want to look into recency, frequency, and monetary value of a customer, right? What does recency mean? Like I have calculated all of this here, and I'll show you that. So you first of all, you have your data frame, you drop all the problematic rows and everything else, and on the basis of the customer ID, we want the number of days since his last purchase, the number of orders he has placed uniquely, and his total sales. So that would be recency, the frequency of his orders, and maybe the total monetary value of that customer. So that is what RFM means here. So based on that data, we are trying to divide the customer into three different segments, let's say, or three or more different segments. So that I initially did with basic k-means, and this is the score, and which was pretty bad. So then I looked into what else can I do. Like what are the different, or what are the other things I can do with it. And by the way, so when I actually classified, when I actually clustered using this method, I got these three profiles, for example, cluster labels 0, 1, 2, and these are some of the metrics I was trying to see. I got to see what kind of recency, frequency, or monetary value are there for the different groups of customers. In this case, it's like for cluster one, 82.2 means the days elapsed since the last purchase has been 82 days only. The frequency means that okay, on an average they would buy like 8 products, and the monetary value is this, the total sales. Similarly, for group 0, the recency is like pretty bad, 549 days since the last purchase. They only bought like three to four products, and their monetary value is also pretty low. Already you can see that we can already sort of divide the customers into certain segments, but is that a very good way to do it? That we'll look into later. So I looked into other methods to do it, and I came across something called autoencoder, which is actually a sort of neural network setup which can be used to do this sort of clustering. Now I will not go in depth into what it is doing and how it is different exactly. I'll show you what kind of difference it makes. So this will give you some idea. Let me zoom it. So if you see, these are the cluster labels, okay? 0, 1, 2, okay? And this is one of the original k-means clusters. And if you see here, there is no clear demarcation of the customers. And if you ask me what is this, what is this dimension, embedding dimension 1 and 2 that you're showing me? So what autoencoder does is it does something called dimensionality reduction, which I'm not going to go into too depth, but I'll tell you this. Let's say there are three parameters here: recency, frequency, and monetary value. Now these are not linear parameters, and there is no linear relationships between any of them. What this autoencoder does is it compresses those three parameters into a two-dimensional space, also called a latent space. Like that gives you a better idea of where a data point actually lies in relation to the others. That is the thing. You cannot intuitively tell me whether recency, if someone has high recency, whether they would have high monetary value or something. That is not a linear relationship. So autoencoder uses neural network, uses the inherent neural networks to learn the patterns between these features, and it compresses it into this two-dimensional latent space. And then we can apply k-means on top of that two-dimensional space, two-dimensional data, and that may give us better results, and that is exactly what happened here. So this is k-means clustering applied on top of the 2D autoencoder embeddings, and you can see there is a very clear demarcation between the different customer groups. Like that is what extra that I did here. Like you can do the normal k-means clustering on the basic RFM, the recency, frequency, monetary value of the customers, but that may not give you very good results, because again the relationships are not very well understood or linear. But if you take help of this autoencoder neural network, it will learn the patterns between these three values, and it will compress it into a more natural, more intuitive uh, latent space, where when you apply the k-means, it will give you way better results. Now again, this does not require you to know deep learning in depth. You can you can maybe explore about it a little, like what autoencoder here actually does, and I mean, and you can see that even if you are doing only basic machine learning in an industry setup, maybe you will have to use whatever sort of tools are necessary to get to a particular result, to improve your results, so to speak. We have already used neural networks earlier in this project when we were generating the synthetic data, right? So yeah, that was what we did here, and this enabled us to classify the customers into into better clusters. And you will see how that changed the scores. Uh, Right. The silhouette score. Mhm. And yeah, 67% improvement. I should have printed it out here. Yes. Oh, sorry. Yeah. Here actually you can see the silhouette score, which tells you how good of cluster how good your clusters are. For the original k-means was only 37%, like only 0.37. Whereas in case of these autoencoder embedding, it is 0.62. So there has been a significant improvement in the silhouette score, and this is pretty good at this point. So that's what I wanted to showcase here. So definitely you can explore this a bit, and if you want to know understand more about what silhouette score is, it's again simply speaking, it is the judge of clustering quality. Right. Okay. Now we will look into. Okay, now we have these values. Now what I did was I calculated a few other values like recency, frequency, monetary value, mean. I have already shown you this for the autoencoder clusters, and then um, I also did quantile clusters. If you remember, we had used this methodology earlier as well in our EDA, where we are basically we are doing the segmentation on the basis of the quantiles. Like here we have the recency, frequency, and mean, right? On the basis of on the basis of whether the mean count on the basis of the mean and the count, we can divide the customers into three segments, so to speak. So based on that, we can divide. In my case, I've divided it into three total categories. The top 33% go into super loyalists, the middle 33% into high spenders, and the bottom 33% into dormant customers. That is basically the quantiles that I have divided them into. And when we get the values of recency, frequency, and monetary value for these make a lot more sense now, basically, and the customer count is almost equally divided between the three clusters. This may not be what you want, though. Like you can have other again, I mentioned some people have 5 tier rankings for their customers, some have 4 tier rankings, 3 tier rankings. So and even there you can have different percentiles for each of the rankings. Maybe top 5% you will have in the first tier, top 20% in the next, 20% in the second tier, next 75% in third tier. That is up to you. So this is just one method in which I have done this, and you may choose not to do it. Okay. So next I have utilized Gemini, or I just integrated LLMs here. So now we have this data, right? We have the recency, frequency, and monetary value data for each of these segments of customers. Now let's imagine that we want to send a memo to our CEO saying that, hey, or to our market specialist to create particular goals for these segments of customers. So how would we do that, right? So one technique that typically is used in such marketing teams is persona generation. Like if you are a marketing strategist, then you would create personas for each of the, like, who represent this particular segment of customers. Now the best way to showcase it is here. uh, let's say customer segmentation. So what I did was I created a prompt and I gave it the recency, frequency, and monetary value data for a particular for a particular segment of customers, and it generated a persona title. Like, what are the typical things that it is noticing for that particular set of customers? So, for example, here this is for the super loyalists. The persona title it has given the established loyalists. So this is generated by an LLM. So they will do this. It's sort of like a storytelling thing. It's better, in a way to explain to a business person like what we expect from customers who belong to this particular segment. For example, meet Rachel. She presents the bedrock of her customer base. This and that. She's a busy professional in late 30s or 40s. Basically, this is also something that all of us have at this moment. If you go into your Google data, you would see that based on the kind of things that you browse, the kind of websites that you visit, they have an ad persona created for you. Actually, if you go and look into your my data section of Google, you would actually find that. So this is similar to that in that respect. They will have what are the key attributes of this person: high lifetime value, brand loyal repeat purchaser, high average order value, and maybe an infrequent purchaser. And what are the motivation and needs of such a person? They seek quality and durability, they need trust and reliability, they appreciate recognition, something like that. And what can be some actionable marketing strategies if you want to send advertisements to this person? So like personalized re-engagement, send targeted emails, like how would it be different from say the bottom 33%? In this case, see, the actionable marketing strategy is different. Execute a high impact win back campaign, launch a feedback oriented survey, something like that. So basically, again, what I did here is something that you can do at any stage of this ML workflow, by the way. Like if you have a set of data that is very clearly cleaned and everything, and you have generated some insights, you can utilize generative AI to create understandable insights from it, basically like something that will be easier to explain to someone who is non-technical. That is the purpose here, simply. So coming back here, so this was the persona generation prompt. If you, I'll just show you the prompt here. So this is the prompt that I had used. Role and goal: you are senior marketing strategist and expert data analyst. This is prompt engineering. Translate quantitative customer segment data into rich, actionable business persona that our marketing team can use to guide their campaigns. Context: we performed a deep learning clustering analysis on our US-based e-commerce customer base and have identified several key segments. I'll provide you with a statistical profile for one of the segments representing the top tier of our customers. Task: I just told it what all do I need from it: personal title, the narrative summary, actionable marketing strategies, the tone. And here in this segment, this is where I'll give it the proper data that we have generated here, like whether the segment name, the recency value, the frequency value, monetary value. I will give it here, and I will send it to the LLM to generate me the persona persona here. So this was the customer segmentation bit of it. Now, I guess we will move on. I mean, I'll not. I think we have been on this live for quite some time. I'll just explain. I'll just introduce you to another last thing, and that will be SHAP. And this has to do with explainability of machine learning models. Like if I tell you that you know what, a high discount makes it makes no sense to sell in the central region of the US because the profitability is not that good. Now stakeholders may ask, how do you know that, right? I mean, you can show that okay, certain rows are showing something, but that is not good enough. How do you know which features explain the profitability of a particular transaction? So this is where SHAP, which is also the full form of it is, I think, shapely additive explanations comes in. So it utilizes very, like, it's very novel and mathematical, and even I don't understand the entirety of it fully at this point, but it uses cooperative game theory to kind of predict which features in our machine learning model are more important for the target variable than which other features, basically. So I'll show you the generated SHAP plots, because those would be the more interesting parts. So when I generated the SHAP summary plot, what it told me was the profitability is very strongly correlated with subcategory binders. Huh. Then the region, central region, then segment, which is home office, then quantity, and so on and so forth. And there is this B swarm plot, so that tells me whether the particular transactions based on this particular feature values were profitable or not. So wherever you are seeing that the data points are clustered towards the left, that means those are loss making, and wherever it is clustered towards the right, those are profitable. And these are just magnitudes basically. So here we are seeing that we are making more losses in subcategory binders. We are making more losses in central region. We are making a whole lot of profit in home office segment. More quantity also is also related to more profit. Paper labels, they are also profit making. Appliances, profit making. West region is very well profit making. But so all of these gives you here, this is the interpretation. A positive value on the x-axis pushes the predicted margin higher, and a negative value pushes it lower. The color indicates the original value of the feature, red for high values and blue for low values. This plot reveals the most significant drivers of inherent profitability, basically. So this will tell you, it will give you some insights into whether into what kind of business actions you should take. Like I would, if I was the CEO or marketing analyst, I would say, okay, maybe we should push the home office segment more. Maybe we should go and investigate the central region to see why we are making losses in that region. And maybe we should look into what is happening with these subcategory binders. Are we giving too much discount here? What is happening? So if I go back to my dashboard, this is another segment. This is not included in the notebook, but let's say based on the key findings of this project, you want to create a marketing strategy brief. What would that look like? So this is where I have again used an LLM. In the backend, it is calling Gemini Pro, and it will be generating a strategic memo based on a prompt. I'll show you that. Let's see. Let's wait for a couple of minutes to see if it generates. Yep. So see, it has generated this memorandum. The formatting is bad, but that is fine. Our customer has yielded critical insights into customer behavior and profitability drivers, and we have identified distinct customer segments, key areas. Key finding one: it reveals a clear customer segmentation. One third fall into super loyalists, one third into high spenders, one third into dormant customers. Key finding two: what drives our profitability? So deals categorized as binders erode margins because they are, as we saw, that they are very loss making. Similarly, central region is also on the other hand loss making. Home office segment and high quantity deliver strong profitability. So these findings highlight these things. New capabilities and recommendations. We have developed two highly accurate predictive tools. That deal desk classifier that I have shown you here. This one, based on let's say central region. Let's say I'll go for corporate. Let's say I'll go for product category furniture, and subcategory maybe, I don't know, furnishings. And if I give 12 to say 21% discount or something like that, so it says that okay, it is profitable with good confidence, and the predicted total profit is 28.36, and the profit margin is 19.72%. Here you can also analyze the profitability on the basis of any existing customer or a new customer. You can also give a particular postal code, because if you remember, we had used these features when we were training our models. You can increase or decrease the quantity. You can increase or decrease. Oh yeah, here it will give you a realistic range for that particular category and subcategory, basically. Let's say here I'll give $100, or maybe I don't know, $60, $750, and profitability. Okay, it is still profitable, and but the implied profit margin is not that much. So anyway, so this was the prediction suite, which will tell you whether a given, for a given customer segment, region, state, product category, subcategory, and sales price and quantity, whether a particular deal would be profitable or not. So this is what was there in the strategic insight memo as well. And yep, that was pretty much the entire project. I'll go through just a couple more things here. So this was the entire workflow here that I had done. I'm not sure how in depth I was able to explain each of these things. But I am sure that the mistakes that I have done, I have been able to showcase that. I have also used Streamlit to create this dashboard, which you see here. And in that, I'll show you that here, see, models, right? These models are saved in my project folder. And we are using this cache resource thing to have it saved in memory so that it doesn't have to load it every time. So Jobly will load all these classifier, forecaster, and the market basket analysis models when the Streamlit library starts, when this page starts up, and it will also cache the data, like the Parquet data that we have created. And these are just ways to utilize Streamlit. It is not a full-fledged front end, but it is good enough for this purpose. And these sorts of lookups and all, also you can cache these data. And yeah, this is a GenAI configuration. I was using Gamma 3, it seems, instead of the Gemini Pro. That is fine. It doesn't matter much because we're not doing some very complex analysis here. So Gamma 3, by the way, is free. If I recall correctly, I mean, you can get the Google API key from AI Studio .google.com. This is another name dropping I'm doing, and yeah, this is a way to and yeah, this was the prompts that we have done, that I have used. I have already showcased this, so I think that is pretty much what I had to share. Priya, do you want to take anything else?
Perfect. I think it was a very nice discussion overall. And yep, thank you so much, Arijit, for sharing your complete, you know, stuff, insights, whatever you have gained in this specific journey. By the way, is this your first project which you have created end to end, or previous to that also you have created any projects and you are used to it? I'm asking this question
I
because
mean,
many people usually ask from me in the discussions. I mean, whenever I used to connect with them, ki, we are a beginner, so how will that be possible for us to do this implementation? What's the right path we can follow? Because initially we face a lot of
so
issues, right?
yeah,
Yeah.
yep. I'll show you. That's a good point. You know what? I'll show you something. Yeah. Is
Hmm.
my screen still sharing?
Yeah.
Okay, I'll show you something. Okay, so don't be disheartened and don't be scared or anything. So this is my beta notebook. I'm showing this simply because it is extremely messy, and I won't say the final one was also very good. But see, I'll tell you one thing. When it comes to end-to-end project, if you start it by thinking that okay, I'll build this perfect thing in one go, not going to happen. Not This is not how it will work. You will do one thing, you will mess up. Like I'll show you, where is this, that deprecated part, I'll show you. Okay, classification, yes. I'll show you this. I Hopefully the results are here. Yes, just look at the precision, the scores. Okay, these are horrible. Look at this, actually, the classification report for random forest. Okay, um horrible scores, simply speaking. And this was when I was doing, I mean, I'm not sure which one this was, but yeah, I was getting horrible scores here. And what later on, oh yes, look at this, this is brilliant. Like from linear regression, the R squared value was negative, right? This was for lasso regression, it's like 0.01. For XGBoost, it was minus negative 0.314. You know where this came? So I was trying to predict the lifetime value of a customer. Okay. I mean, what I did here was different, right? I did customer segmentation, but aside from that, I was thinking, okay, what if I can, predict the lifetime value of a customer from the beginning, like from the first purchase, let's say. And that is what I try to do here. See, I use sales price, quantity, discount, profit, and some other categorical features. And basically, I try see the clean data. The group by is here. customer ID I have tried to do group by using total profit, and I have done some other data data engineering here, feature engineering. But ultimately, it gave me so horrible scores that I don't know. Maybe I would have just given up at that point. But then I thought, like, I didn't think. It's not like I thought. I did some more analysis, and I understood that okay, we do not have enough data to predict whether a customer's lifetime value would be great from the first purchase. Then I tried another method. I thought, okay, what if we take the first 90 days, right? I think yes. So this was where I was trying to do it for the first 90 days. Let's see if I can show you that as well. Oh no, this is profitability. Yeah, profitability. That one also I will show. So basically here I think I was doing that. I had just commented it out entirely because it also gave me very bad scores. Um, so pretty much my first attempts at understanding, like, I have this data set, what will I do with it? First, you can have some ideas. You can think, okay, I'll predict profit, I'll predict customer lifetime value, I'll predict this, I'll predict that. Not all of them will work out. Some of them will work out, and some of them will work out too well. That is what I was trying to say. I think this cell I didn't copy paste earlier. See, this is what I was talking about earlier. See this thing. So this was profitability classifier I was trying to make, and the scores are great, right? Like 96% precision, 98% recall, 97 F1 score, and this is completely useless. This is completely useless because in the features I have quantity, discount, and sales price, and in the target variable I have whether it is like profitable or not. The thing is, when you do that, again, I explained earlier, right? Target leakage. Read about it. Basically, profit is a mathematical formula when you know the sales price and the cost price or the discount, right? That is something we have learned in arithmetic. I did not consider it earlier. I did this entire thing and I was very happy, right? 96%, 97% value I am getting. So this is a learning opportunity, basically, so to speak. um, and this is what my suggestion would be for others as well. Don't don't think of doing everything at one go. You can start small, do one thing at a time. Like here also, if you see this messy notebook, first I like tried out customer segmentation. Do you know why? Because in the EDA step I had already done this. I already had this RFM analysis thing done, but it was from a statistical point of view. I had done quantiles there, like QCut I have used there, but here I was trying to do it from a machine learning standpoint, and to do the cluster to use clustering algorithms to do it instead of instead of using quantile cut, right? So since I was already familiar with it, I went with this in the first place. Um, then I thought, okay, I'll do some classification, some regression. Classification means can we predict the long-term value of a new customer based solely on the very first purchase? It didn't work out. Can I do it on the basis of the first 90 days? It didn't work out. Then this one was what? Oh, transactional profitability. It was the 90. I think the 90 days one. I think this also didn't work out. It also gave me very bad scores. So then
So
the profitability.
indirectly,
I
what
done.
he wants to
Yeah.
say is ki, whatever is the picture you are seeing right now, the results which you are seeing right now, there is a lot of failures happen in the back end, and this happens with everyone. The key mantra is just keep on doing, keep on exploring, keep on seeing that okay, if this is not working out, what other stuff I can do, what other things I can explore, so that my whole analysis will be appropriate. This complete domain is all about experimentation, and if you will keep on doing the stuff, your mind after some point of time will get trained ki this is how, if this is not working out, this might work out. Intuitively you will start thinking and you will be able to reach to one final solution at the end of the day. It might take a lot of time in the start, but as and when you will keep on preparing these kind of projects, things will become easy for you, things will become very smooth for you to get the crux of it. And It's not about easy or smooth. It's about you will start finding it fun. You will start enjoying these kind of challenges in your work, and that is what makes you data scientist, or what you want to become, machine learning engineer, whatever be the case is. Right, Arijit?
Yeah. And I'll just try to I mean since I'm not an industry professional in machine learning domain specifically, and honestly, this project was the first time uh, I mean I did the ML workflow completely from start to end, and not just okay I just predicted a particular thing and that is the end of it. I calculated the accuracy, but this was the first, I would say, the almost end to end project in the machine learning domain that I have done. I'm not
Mm-hmm.
very familiar with it even now. I have done a lot of mistakes. This project can be improved a lot. I mean, I can use better data sets. I can use better techniques in the EDA process. There's a lot, and this is another thing. In just very recently, when I was looking into how MLOps is done in the industry, I got to know about Apache Airflow and Kubeflow. So basically, all these scripts that I have written, yes, these are great. I can manually execute each one of them, and they will do what they're supposed to do. But in a production environment, industry, they will have a sort of I mean, Priya can say more about it, but I got to know about Apache Airflow and Kubeflow, which they use to orchestrate these scripts and to automate the execution of the scripts. If you want to talk about it, you can maybe give us some insight into what happens in a actual machine learning engineer's life cycle.
So majorly right now, because things are going towards automation side, right? We can automate all of these things, whatever he has talked about, whatever things we are learning, the complete pipeline which I have just now talked about in the starting, with the help of these specific tools. The only point is, even though the things are going for automation side, even though you have just with a button you have to click and things will go in the production pipeline in the back end. The only point is the expertise, the amount of level of expertise which were required, I would say few years back versus now. So if you will compare, people usually feel that today is the time where we don't even need that level of expertise and we can directly go ahead and do the task because of these kind of tools that we will be having. There is no need to manually write something out of it. uh, I feel it bit different. The point is ki over here we have these amazing tools available, because of which now we have to examine whether everything is working fine or not. So we are in the era where we will be working as a reviewer, and we have an amazing tools not only in the machine learning work but also in deep learning, in generative AI, in all the different domains that we have in data science. You will be considering yourself as a reviewer. So when we are saying that we're reviewing something, you can understand the amount of level of expertise you are requiring, right? Because these tools are currently, I would say, not that much matured. It is working currently in the production side, but not in that much extent they're matured that everything is working very smooth, or every result which you're getting over here is up to the mark. And if we don't have that level of idea, if we don't have that level of expertise, obviously things might go completely wrong. So the only point over here is the right kind of foundational knowledge is required right now. It was required previously also, but the importance is more now, because now you might not be working on writing the code end to end in the production part. You will be working as a reviewer, you can imagine, where you have a tools which will be working for you, kind of. You can consider them as your uh, team members who are working under you, and you're just coordinating with them, you're writing a script to them, and they're doing a task for you. And automatically all of these stuffs whatever we have talked about right now will be done. But we as a reviewer have to understand and check that whether the things are working in a right manner or not. And that is where you can explore. I mean, I'm working on a project, might be by the mid of this year I will release that. That is all about talking about these tools, plus working on model explanation part, interpretation part. For example, today Arjit have talked about Shapley values. There is one more term called as lime, you can explore that. uh, I'll release the content about this in a lot more detail with a proper explanation, because I myself have felt that there is not that much content available on the web where people can go and explore and see the power of this in order to fetch the importance values of the features and how the things are working in the industries. So all of these things, I'm really hoping that I will be able to do and curate interesting stuff out of it by the mid of this year and release it for you all. But yeah, that's what we have in this specific session. I think it's almost 1.5 hours long, quite huge discussion we have done. So I really hope that you guys have enjoyed this. I also have another meeting to go. So I will wrap up this session for now. And I will see you all in the next upcoming discussion. Maybe Arijit might come again with something new product, with something new, amazing work. Or maybe if he's interested, maybe I'll collaborate with him in future for a teaching part per se. I can see he can teach really well and he can explain the things in a really good way. So thank you so much, Arijit, for spending this much amount of time. Uh, you know, and if you guys have any other questions, anything you want to ask, you can let us know in the comment section of this video. Either he or me will try to respond to you guys as soon as possible. Also, today is Basant Panchami. It's a very good day, right? It's a very auspicious occasion where we try to do our discussion. A day which celebrates knowledge, clarity, new beginnings. And I really hope that today's project discussion, which Arijit has done, planted at least, I would say, one strong idea in your head, in your mind. Learning is not about watching sessions. It's not about taking inspirations from uh, external inspirations or motivations from other. It is about internal things, and I really hope that you will apply these concepts. You will try to break the things, fixing them, building again. And as Arijit has mentioned, that how he has also faced in the initial part the challenges and how multiple trials helped him to get this polished project out of it. So please take this as an inspiration and try to work on it. And I am really hoping that you guys will be able to also create something amazing projects, as a part of your career, which will help you to build great products, which will help you to crack multiple great product based companies. And with that, bye bye everyone. See ya. We will see you all in the upcoming discussions. Thank you so much, Arijit, once again.
Thank you. Thank you for the opportunity. Thanks.